Hi, everyone. My name is Harini, and I'm excited to present our work on characterizing interpretability stakeholders. So a lot of recent work has focused on ways for people to understand, question, or probe machine learning systems. But one question we found ourselves asking about this work is, who is it meant for, and is it actually serving their needs? As an example, let's take a clinical decision aid system in a hospital. Doctors need enough information about the recommendations to justify their decisions. Patients probably also want confidence in the recommendations and to explain them to family members. The developers who built the system might want to monitor its performance, and physicians and patients are also well suited to provide them useful feedback about errors. And there are probably others who care about the system, like supporting medical staff, regulatory agencies, or the people whose data was used to train it. As we can see, each of these stakeholders is coming from a different place, and the type of insight into the system that will be relevant and understandable to them is probably very different. Existing work thinking about how stakeholder needs differ has typically characterized people by expertise, so things like AI expert or AI novice, or by their role, so model creator or decision subject. And then the needs of these different groups are extrapolated from their expertise or role. So AI experts want to be able to improve the system performance. Auditors need to be able to detect bias. Model executors want to make good decisions, and things like this. The problem is that this mapping scheme is limited. For example, it means that we're overlooking people without formal machine learning expertise who are well suited to catch model errors, like the doctors and patients in the previous medical example. In part, this is because the type of expertise considered is typically just AI or domain expertise on a linear or binary scale. In other cases, the categorizations mask heterogeneity. In our previous example, doctors, patients, and families might all be considered model executors, since they need to make decisions using the model's recommendation. But the information and visualizations that will be useful to them might be pretty different. So in our paper, we present a different kind of framework that decouples someone's knowledge from their needs and defines each of those things in more granularity, giving us a more expressive vocabulary to discover and design for a wider set of stakeholders. The first part of the framework decomposes expertise into different types of knowledge in different contexts. We include formal, instrumental, and personal knowledge, which can manifest in machine learning, the data domain, or the milieu. This last context refers to the physical and sociocultural environment in which the human-AI interaction occurs. This more granular and two-dimensional breakdown helps reveal important differences that were obscured by broader categories. Our framework also tries to expand the discussion around expertise, in part by revealing the heterogeneity in the group typically categorized as non-experts or end users. By including personal knowledge, we hope to prompt research around designing with stakeholders for their personal knowledge. And by including the context of the milieu, we hope to formalize the need to situate explanations in broader social and historical contexts. The second part of our framework is focused on stakeholder needs. We compiled needs that were described in a range of different papers, from HCI studies to legal analyses, and organized them in terms of some of the latent relationships we noticed. We found that there are some overarching long-term goals like trust and understanding. These are built over time through meeting shorter-term application-focused objectives people have, things like debugging or contesting model outputs. And then there are immediate tasks people perform to achieve those objectives, like detecting a discriminatory prediction or understanding what features the model is using. This organization can help reveal the compositionality in this space. A given task might be useful for several different objectives, or many tasks might be needed to achieve a single objective. And higher level goals are built up over time as users' objectives are met. When we put the two parts of the framework together, a key point is that stakeholder knowledge is decoupled from their needs. And this opens up new spaces for research and design that were previously underserved. If we return to our medical example, recall how prior frameworks might have ascribed the need to improve the model to developers with formal machine learning knowledge. Using our framework, we might end up discovering that hospital staff with instrumental domain knowledge share this need, along with patients and families with rich personal knowledge, and possibly many others. This is not to say that all of these stakeholders would benefit from the same interpretability tool. They almost certainly would not. Instead, we hope that our framework can highlight those stakeholders who are not currently at the focus of our current designs and pose research questions about what it would look like to build tools specifically meant to meet their needs. There's a lot more detail and examples in our paper, so we hope you check it out, and we're happy to answer questions or discuss further. Thank you.